Okay, so in part 1, we learned how to determine if a solution was an acid or a base by comparing the concentration of hydrogen to hydroxide. However, a lot of people tend to struggle by comparing those really tiny numbers. So we use the pH scale to express the concentration of hydrogen, and the pH scale is a little bit friendlier scale to use to determine if something is an acid or a base. So again, just a reminder, the scale goes from 0 to 14. Anywhere from 0 to right below 7 is an acid. 7 is neutral, and then anything higher than 7 to 14 is a base. So to calculate the pH, we just take the negative log of the concentration of the hydrogen ion. So for example, in neutral water, the concentration of the hydrogen ion is 1.0 times 10 to the negative 7th moles per liter. So if we want to calculate the pH of this, we just put it into the calculator exactly as shown. So you go negative log, and then when you hit the log button on your calculator, a parentheses should pop up. So we just type in 1.0 times 10 to the negative 7th, close the parentheses and hit equals, and your calculator tells you that the pH is 7.0. So it turns out if the coefficient of the concentration is 1, then these are really simple and you don't even need a calculator. So coefficient is this number right here. So the large number in front of the times 10. So this is your coefficient. Okay. So if this value is 1, like it is here, then these are the easy problems. Okay. If you notice, that exponent just becomes the pH. Okay. Now the pH scale goes from 0 to 14. There's no negatives. So you just drop the negative. So instead of negative 7, it's just a pH of 7. Okay, so we're going to find the pH together. So let's say the concentration of hydrogen is 1.0 times 10 to the 10th. Okay. What is the pH? So we're going to look. This one has a coefficient of 1. So this is an easy one. You don't even need your calculator. So we just look at the exponent. Okay. And this exponent becomes the pH. And we just don't include the negative. So the pH becomes 10. So then if the pH is 10, is it an acid, a base, or is it neutral? All right, and since 10 is greater than 7, this solution is a base. All right, this time I give you the pH of a solution, which happens to be 6.0. We're going to find the concentration of the hydrogen ion. So this one is also a simple one. Okay, so because it's 6.0 even, I know it's the back to the easy one. So we also don't need our calculator. So for the easy ones, the coefficient is 1, and then it's times 10, and my pH just becomes that negative exponent. Okay. So this 6.0 just becomes the negative exponent. Okay, so now we're going to look at some different equations. So let's say we want to know the concentration of hydroxide ions instead of hydrogen ions. That would be calculating something called the POH. So the POH is just the negative log of the hydroxide concentration. And then we can also find POH or pH using the pH scale. So POH plus pH has to equal 14. Okay. We can rearrange this equation and solve for pH. So pH is 14 minus POH. Or we can rearrange it to solve for POH. So POH is 14 minus pH. And then finally, we can also calculate the concentration of the hydrogen ion or the hydroxide ion. To find hydrogen, it's just 10 to the negative pH, and hydroxide is 10 to the negative POH. So pause the video and make sure you get all of these equations down in your notes. Okay, so we're going to use the equations on the previous page to help us solve these practice problems. So the first one is, what is the pH of a solution if the concentration of OH is 4.0 times 10 to the minus 11? There are multiple ways to solve this one. The simplest is to find the pOH first. So pOH is minus log of the concentration of your hydroxide. So I'm going to solve for pOH. So I'm going to type minus log into the calculator, and then 4.0 times 10 to the minus 11. So when I type this into my calculator, I get 10.4. Okay. But this is the pOH, and I want to solve for the pH. So now I'm going to use the equation that pH plus pOH has to equal 14. Okay. So if I rearrange, pH is going to equal to 14 minus pOH. So I'm going to take 14 minus 10.4. So I end up getting 3.6 as my pH. Now we're going to calculate the pH when the concentration of the hydrogen ion is 5.0 times 10 to the minus 6. So to calculate for pH, we do minus log in the concentration of hydrogen. So when I type this into my calculator, I'm going to go minus log 5.0 times 10 to the negative 6th. And when I type that in, I end up getting 5.3. So the pH of this solution is 5.3. All right, now we're going to calculate the pH when the concentration of hydroxide is 4.5 times 10 to the negative 11. Again, since you're given hydroxide, we're going to find the pOH first. So we're going to take minus log of the concentration of OH, so 4.5 times 10 to the minus 11th. And when I type it into my calculator, I end up getting 10.3. Okay, but that is pOH. So then now pH is 14 minus 10.3, which is going to equal 3.7. All right, and then this time we're going to figure out what is the concentration of the hydrogen ion of a solution with a pH of 3.7. So this time, we know the pH, and we're going to solve for the concentration. And so we're basically going to undo the log. So the concentration of hydrogen is just 10 raised to the negative pH. So we're going to go 10 to the negative 3.7. So if you type this into your calculator, you should end up with 2.0 times 10 to the minus 4. All right, and then the final thing I want to mention is just when we mix acids and bases together, we call this a neutralization reaction. So acids and bases neutralize each other. And so if you look at the diagram here, we mix an acid and a base as our reactants. And then whenever we mix an acid and a base, your products are going to be water and some type of a salt. Okay? So you just need to know when we mix acids and bases, they end up neutralizing each other.